For our seventh lesson, we're going to take a look at the distance formula. And really, the distance formula is nothing new. In the last lesson, we looked at the Pythagorean theorem, and we saw that you can use the Pythagorean theorem to find the length of a segment by taking the segment and turning it into a right triangle, and then using Pythagorean theorem. So basically, the distance formula comes from Pythagorean theorem. So you can always use Pythagorean theorem, or if you prefer, you can use the distance formula. It's kind of like with finding slope, you can count the boxes to get the rise over the run, or you can plug into the formula to find the slope. It's completely up to you, whichever you like best and whatever works best in each situation. So here's what we're going to look at. In this example, we have a segment. We have point A, which has coordinates 2, 3, and point B, whose coordinates are 14, 12. And what we're going to do is sketch a right triangle that could be used to calculate the length of AB using the Pythagorean theorem. So I'm just going to go ahead and turn this segment into a right triangle. So I'll draw my horizontal and my vertical segments. And then go ahead and count the boxes to find the distance, the horizontal and the vertical distance from A to B. So it looks like my horizontal distance is 12, and vertical would be 9. And so now I can use that to find the length of AB, which is the hypotenuse of that right triangle. So I can go ahead and do leg squared plus leg squared. That should be 9 squared, but I squared it anyway. And it equals the hypotenuse squared. So 12 squared is 144, plus my 9 squared, which I already have, is 81, and that equals x squared. And now I can go ahead and I can add those two together. So I have 144 and the 81, and that gives me a total of 225. And then yesterday we saw how to get rid of that x squared by taking the square root of both sides, and we can go ahead and see if this is a perfect square if we don't know already. And so the square root of 225 turns out to be 15. So the length of our hypotenuse on this right triangle is 15, or we can say that the length of the segment that goes from A to B is 15 units. All right, so let's take a look at what we did. Basically, we had to find the distance from A to B on the horizontal axis and the vertical. And so if we take a look at those two values right there, what we could do to get that distance is we could take the x values, because this is a horizontal, which is related to our x-axis. And so we could take those two x values that we have in our point, we could subtract them. And that would give us the 12. And then to get the y values, we could take the y values for points B and A, and we could subtract those, and that would give us our 9. So if you think about it, what we really did to get the legs is we took our x values, so the second x value minus the first x value, and we took the second y value minus the first y value, and we subtracted them. And we came up with the 12 and the 9. And then what we did is we squared both of those values to get 144 and 81. So we took the difference in the x values and squared it, took the difference in the y values and squared it, and we added them together. And then to get rid of that x squared over here, we ended up taking the square root of what we got when we added the sum of the squares of the two sides of the right triangle together. So really, we have the square root of all of that stuff that we did before. And that is the distance formula. So basically, what we did here is the work that's required to find the distance formula. The distance formula is just a formula that you could memorize like anything else. But again, you could always draw the segment, turn it into a right triangle, and solve. The distance formula is just solved so that you can find the length of that segment, which is the hypotenuse of the right triangle. Okay, so the next thing that we're going to do is take a look at an example. This time it says find the distance between the points 1, 5, and 3, 11 in simplest radical form, and draw a triangle to support your work. So what I need to do is I need to find out how far apart my x values and y values are. So I'm going to subtract my x's, so 3 minus 1, And then I'm going to subtract my y values, 11 minus 5. And then what I'm going to do is I'm going to square both of those and then add them together, and then I'm going to take the square root of my final answer. So if we go through and do this, 3 minus 1 is going to be 2, and 11 minus 5 is going to be 6. And then I'm going to go ahead and square both of those. 2 squared is going to give me 4, 6 squared is going to give me 36, and then if I add them, 36 plus 4 is 40. And now if I check that, if I take the square root of 40, it turns out to not be a nice whole number. So what that tells me is that I have to either write it as a decimal or simplify, and I go back into the problem to see what they're looking for, and they're looking for the answer in simplest radical form. So I need to simplify the square root of 40, so I need to find a perfect square that divides into 40, which would be 4. I can rewrite it as 4 times 10. The square root of 4 is 2, so 2 is going to pop out, and 10 has to stay in. So the length of that segment in simplest radical form is going to be 2 square root 10. So then to draw it, what we really have here is a leg that is 2 units long, another leg that's 6 units long, and then we have our hypotenuse whose length is 2 times the square root of 10. Alright, in the last one on the front, if there are 2 arbitrary points, just any 2 points, x1, y1, x2, y2, then use the approach that we took up here to find the distance between them. So basically we subtracted the x values, we subtracted the y values, and then we squared both of those, added those values together, and then we took the square root. So basically what we have here in our right triangle, if we were to draw it out, is the distance, this side right here, is going to be equal to what we get when we subtract our y values and what we get when we subtract our x values. So this side here is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so now that we've discovered the distance formula, we're actually going to go ahead and use it. So here we have distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. And underneath it says you'll use the distance formula in this course and many others. Never forget though that it's really just the Pythagorean theorem applied to in the coordinate plane. So what we want to do here is find the distance between each set of points using the distance formula. So we have 2 points, and so our distance formula is x2 minus x1, so 15 minus 3 squared, and then plus y2 minus y1, so 7 minus 12 squared. And then we can go ahead and clean that up. 15 minus 3 is going to be 12, and 7 minus 12 is going to be a negative 5. And so now we can go ahead and square those things. 12 squared is going to be 144, and negative 5 squared means negative 5 times negative 5, which is a positive 25. When you square a negative number, you're always going to get a positive number. Now, be careful on your calculator, because if you try to type in negative 5 and square it, it's going to give you a negative 25, because what it sees is negative 5 squared. So it's squaring 5 and making negative. If you're using your calculator, you want to make sure that you put the negative in parentheses and then square it, and you'll get the 25. But really, working through the distance formula problems, just think in your mind, a negative times a negative is a positive. So negative 5 times negative 5 is a positive 25, and then there really shouldn't be any issue. Okay, so now back to our problem. If we go ahead and we add those together, 144 and 25 is 169, and the square root of 169 is 13. So that's the length of that segment. All right, so go ahead and try the second one, again, just using the distance formula. And now for example number 5, we're going to do the same thing, but this time our answers are not going to be nice, pretty numbers, because it tells us that we want our answer to be in simplest radical form. So again, I'll do one with you. We want to subtract our x values, so -2 minus 4 squared, and then subtract our y values, 10 minus 1 squared, and now we're just going to clean it up. So -2 minus 4 is a -6, and 10 minus 1 is 9. And now we go through and actually square those things. So -6 squared is going to be a 36, positive 36, and 9 squared is an 81. And now if we add them together, we get 117. And we have to take the square root of that. So now what we're trying to do is find two numbers that we can multiply together to give us the square root of 117. And so we can rewrite this as 9 times 13. 9 is our perfect square, so the square root of 9 is 3. So this becomes 3 times the square root of 13. All right, so again, go ahead and see if you can try letter B on your own. Make sure that you simplify your answer to simplest radical form in the end. All right, so we can also use the distance formula to prove certain figures have certain properties in the coordinate plane, and this is actually what we're going to look at in our next chapter after break. But for now, if we want to just kind of get a small glimpse at what it's like. So with this one, we're given that triangle ABC has coordinates A, B, and C, and they have it drawn for us. We would like to prove that ABC, triangle ABC, is isosceles. So if it's isosceles, that means that it has two equal sides. And so what we want to do is try to show that those two sides have the same length. So we want to find the length of AB and we want to find the length of AC. And if we find that those two have the same length, then we can say that they are equal. So which two sides appear to be the same length? AB and BC? No, AC, sorry. So AB and AC look like they're the same length. And now we're going to see if they have the same length. So we're going to find the distance from A to B, and we're going to find the distance from A to C. All right, so what I would like you to do at this point is go ahead and practice that. You have your points up above. A and B are the points you're going to use to find the distance from A to B. And then A and C are the points that you're going to use to find the distance of AC. All right, and hopefully those turn out to be the same length.